Hello friends. Okay, we will continue with motion. Now in this today's lecture, we are going to discuss about the some Intext exercise of this NCERT textbook. That is in Intext exercise 1 and 2. Okay, let's see what is that in it. Okay, already we studied about it in one part. We studied about the distance and displacement. Okay, and in the second part we studied about the speed and velocity. So okay, here we are going to discuss about in these two exercises mainly of that. Okay, let's see what is there in that. Okay, first question is, an object has moved through a distance. Okay, can it have zero displacement? Understand? An object has moved through a distance. Some distance it is traveled, that means. Okay, now the question is, can it have zero displacement? Okay, if I support your answer with an example. Now you know that the distance traveled, here it is. Okay, the distance traveled from here, okay, somebody is of traveled up to here. It is that much distance is traveled. Now this is the distance as well as this. Here the important thing is the distance and displacement. Distance is the path traveled. Now it is like this from here. Okay, so okay, from here, okay, like this. This is the path traveled. Understand? So this is the distance. What it is? Distance. Now what is the displacement? This is a straight line from the initial position to final position is the displace. So it is like this. Now suppose now here it is of and we are reaching here. Now what is the distance here? Now this much distance is traveled, correct? What is the displacement here? Any displacement is there? No, zero displacement, because wherever it is started from there only, that is here. So we can see that okay, even some distance is traveled, but what can be? Yes, displacement. Okay, displacement can be zero. The example you can see that of a circle. Example you say. Okay, now the circle, you know that wherever while completing one revolution, okay, you know that wherever it is started, there only it will reach. So what is the distance here? We can say the distance here is equal to 2 pi r. Okay, what is the displacement? We can say that the displacement is equal to 0. Understand? So that is what here. Okay, so here it is the answer. Yes, zero displacement is possible. Okay, if an object has moved through a distance, suppose a body, example is okay, in a circular path and starts moving from, you can draw a diagram also. Okay, now from a point A, here you can say a point A, okay, and returns back to the same point A. Okay, after completing one revolution, then the distance will be equal to the circumference with the displacement will be 0. Understand? Here it is the radius is r, so that we can say that the distance traveled is equal to 2 pi r. Sure? Understand? So here what is the displacement? The displacement is equal to 0. Why displacement is equal to 0? Because it reached the same point. Sure? That is the question. I hope you understand. Now the next question is, look here, a farmer moves along a woody boundary of the square field of side 10 meter in 40 seconds. Understand? What will be the magnitude of displacement of the farmer at the end of 20 minutes and 20 seconds from his initial position? Look here, one round. Okay, side of the, okay, here it is side is of 10 meter. So we can say that here the perimeter is equal to, what will be the perimeter is equal to? It will be 4 into 10, that is of 40. Correct? That is of 40 meter. Sure. Now you know that he completes it in 40 seconds. Understand? In 40 seconds he complete one round. Understand? That means we can say that in 1 second, okay, in 1 second, okay, what distance it will be covered? It is of 40 upon 40. Okay, that is, we can say that 1 meter it will be covered. Sure. Now we can say that the total time taken is, you know that the total time taken is, it is of 2 minutes, okay, 20 seconds. Correct? That means, okay, 2 into 60, correct, plus 20. Okay, that is, you know that it is 120 plus 20. Okay, that is of 140. That is 140 seconds. Sure. Now we know that in 140 seconds it is completed. Okay, for one round it take only 40 seconds. Okay, so we can say that now the one round it is, so how many round means how many round it is taken. Okay, we can say that it is of 140 upon 40 because for one round, so it is of 2 2s are 2 7s are, which is equal to 3.5. Understand? 3.5 round it took. Understand? Now this 3.5 round means, okay, from here to 40. Okay, again from second round. Okay, then the third round. Okay, then 3.5. 5 means here, from here to here, this much it is. Okay, that means if it is started from A, then it will reach to C. Now here the question is, okay, what will be the magnitude of displacement? That is very important. No, not the distance. No, 3.5 round it traveled, so the distance, what will be the distance is equal to 3 into 40 meter, correct? That is 120 meter. Okay, plus in 0.5, that is of 20, plus 20, that is 140 meter. The distance, total distance is traveled in that. Now that is not the question, but here the displacement. So displacement is a straight line from the, okay, initial position to the final position, correct? So that we have to find AC. Now how we can find AC is by Pythagoras theorem. It is of AB square, okay, plus BC square. Okay, so you can write this as, which is equal to root of 10 square plus 10 square, correct? So which is equal to, okay, root of it is 100 plus 100, correct? Okay, so which is equal to what it is, 100 plus 100 is root of 2 into 100. Now what is root of 100 is 10, so we can write it is 10 root 2, correct? That's all. Understand? Okay, that is what here. So you can do it like this. Okay, now here, look here, the since 40 seconds farmer move 40, the farmer take 1 minute. Look here, to not in 1 second it cover on. So in 140 seconds the distance covered is 140 meter. Okay, so the number of rotation is along the boundary is total distance upon perimeter. Okay, that is 140 meter is covered and 40 meter is the perimeter. Like that they are done. Okay, but in that sense also you can do. Okay, so okay, after 3 the farmer will reach the point C. Okay, here it is. Okay, that is here. Okay, that is diagonally opposite to the initial position. Therefore the displacement AC is equal to this. Understand? Like this also you can do, and like that also you can. I hope you understand. Okay, next, which of the following is true for displacement? Okay, displacement. Okay, it cannot be 0. Displacement cannot be 0. What only we see it now, displacement can be 0, because if it is of from wherever it start, if it is of reaching there, then what is the displacement is 0 only. So is it true? No, it is false. Now its magnitude is greater than the distance traveled. Magnitude is greater than the distance traveled. Is it true? Now here you know that suppose this here. Now this much distance is. Now what is the displacement? Is straight line is a straight displacement. So always the displacement is, okay, less than or equal to, okay, less than or equal to the distance. Understand? When it is of equal, you can see that if it is a straight line, the displacement and distance will be equal. But in is a curved path, okay, you know that the displacement will be, okay, less than that of the distance. Sure? Okay, that is clear. Okay, so you understand that both A and B are, okay, not true. Okay, not true. Okay, none of are not true. Here none is there. Okay, not true. Okay, now the next question is, now the next second exercise, there the speed and velocity. First question is about the distinguish between the speed and velocity. Now you know about the speed. What is the speed? Speed is the distance traveled by an object in a given interval of time. Okay, distance. Okay, distance means it does not have any direction. Okay, so the speed is also not having any direction. So it is called the scalar quantity. Okay, because it does not have any direction. Now velocity, what is velocity? Velocity is the displacement of an object in a given interval of time. Okay, it is having the direction. Why? Because displacement having the direction from initial to the final position. So we can say that it is a vector quantity. Correct? Now the speed is given by the relation, okay, distance traveled, okay, upon time taken. Velocity is the displacement upon time interval. Understand? Now the speed is of an object can never be negative. That is very important. Speed can never be negative. It can be 0. Okay, but because of the distance traveled can never be negative. Can never be negative. Sure. But the velocity is not like that. Velocity can be negative, positive, or 0. Why? Because we know that if it is moving upward, it is displacement is taken as positive. It is moving downward, displacement is taken as negative. It is taken as like that also we can take. Understand? So that okay, displacement is okay, what it is, negative, positive, or 0. So that the velocity also negative, positive, or 0. Sure, all of you? So that is the distinguish. Understand? Speed. Okay, what is the distinguish? Speed. It's the distance traveled by an object in a given interval of time and does not have any direction. Okay, velocity is the displacement of the object in a given interval of time. It has a unique direction. That is, here we can say speed is a scalar quantity, velocity is a vector quantity. Next, speed is the formula. Speed is equal to distance traveled upon time taken, velocity displacement upon time interval. Now, speed of an object can never be negative. Okay, but it can be 0. Okay, but never it is negative. Okay, but velocity can be negative, positive, or 0. Okay, depends on the displacement. Sure. So we can move to the next one. Okay, here the under what condition is the magnitude of average velocity of an object is equal to the average speed. Okay, here the answer is the average speed is equal to total distance covered upon the total time taken. Average velocity is the displacement upon time taken. Now you can see that okay, both the denominator is equal. So if the numerator is equal, it will become average speed is equal to average velocity. So that we can say that if the total distance okay is equal to displacement, okay, we can say that what we can say, the average speed is equal to the average velocity. It will become equal. Understand? The total distance covered of an object is same as its displacement, then the average speed is equal to the average velocity. So understand it? Okay. Then we will move the other one. Okay, third one. Here look, what does the odometer of an automobile measure? Okay, it is of odometer. What is odometer and speedometer? Two aspects are there. Now, what the odometer of an is the distance covered. Understand? Odometer measures distance covered. Speedometer or okay the speed meter. Okay, what it measures? It displays the instantaneous speed. Understand? Now here look, in this figure, this you can see, this is okay, this dial is of speedometer. This is of speedometer. Understand? But here you can see the distance traveled. Here, getting? Here you can say how much distance we are traveled. This is what the odometer. Understand? Okay. So odometer is the what it is an instrument used to measure the distance traveled by the worker. Okay. Understand? So odometer, what it measures? It measures the distance covered by an automobile. Sure? Okay, so don't be misunderstand. This dial which is showing is a speedometer, but in the below what we will see, we can see how much distance a vehicle is traveled. That is the odometer. Sure? Okay. Then the next is okay, what does the path of an object look like when it is uniform motion? Uniform motion means straight line. Understand? Whether it is of uniform velocity, whether it is of uniform acceleration, let it be. So it will be look like a straight line. Understand? That is right. Okay, so here the last question. During an experiment, a signal from a spaceship reaches the ground station 5 minutes. So time taken. What is the time taken is 5 minutes. Okay, now 5 minutes is equal to 5 into 60. That is of okay 300 seconds. So the time taken is 300 seconds. What is the distance of the? We have to find this. Distance is what we have to find. Okay, now the speed of the light, that is velocity you can say, or the speed s is equal to what it is 3 into 10 raised to 8 meter per second. Understand? You have to find. Now you know that what is distance is equal to speed into time. Correct? That is, we can say what is the speed is 3 into 10 raised to 8 into 300. Correct? So it becomes 3 3s are 9, that is 900 into 10 raised to 8. Understand? So we can write it as a 9 into, okay, it is of 9 into 10 raised to, now this 20 can be added with it. Understand? So it become 10 raised to 10. Okay. Oh, sorry. This, where it is? Minute. Yeah. Okay. Here it is. Okay. Again once more. Here it is. S is equal to what it is. We see. Okay. T is equal to what it is. Also here. What is T is equal to? Here T is equal to 5 minutes. Okay, so 5 minutes means it is equal to 5 into 60. Okay, that is of okay, 300 seconds. Sure. And the other is of okay, we have to find what is, we have to find the distance is what we have to find. Okay, and the speed is given. Okay, what is the speed is given? Okay, speed is given that 3 into 10 raised to 8 okay, meter per second. Okay, so here we can say that the distance is equal to speed into time, correct? So speed is equal to 3 into 10 raised to 8 okay, meter per second into, okay, what it is the time taken, that is 300. So here what it is 3 3s and 9, that is 900, correct? Okay, into 10 raised to 8. Now these two zeros can be added with this 8, so it will become 9 into 10 raised to 10, okay, that much meter. Now this is in meter. If you want, we can convert into kilometer if you wish, okay, not compulsory. Then it become, we have to divide it by 1000, that is into 10 raised to 10 upon 1000. 1000 means 10 raised to 3. Okay, then if it is divided, you have to subtract it. So 9 into 10 raised to 7, okay, that much kilometer. Understand? Like that it will come. Understand? So you can do it like this. Look here. Here the okay. We have the speed 3 into 10 raised to 8 meter per second. Okay, time is of 5 minutes. Okay, that is using distance is speed into time. It is also here it is given that okay 10 this much meter. If you want to convert, you can convert it as 9 into 10 raised to 10 upon what it is 10 raised to 3. Okay, that much kilometer. Understand? So that it become 9 into 10 raised to what it is 7, that much kilometer. Sure, like this. Fine. I hope you understand it well. Okay, practice. If any doubt, you can ask. Thank you. Thank you, children. Bye.